Hello.
Hi, good morning.
So yesterday we have been discussing about statistics, right, guys? So basic descriptive statistics. Ramesh, do you understand?
I have a question.
Yes, please. Yes, please.
Yeah, just 1 minute. Yeah, can I share my screen?
Yes.
Mm, Can you see my screen?
Yes, exactly.
Yeah, actually, this is one of the documents that you shared with us.
Exactly.
I have a question here.
Yes,
Let me do this. Okay. So, so you said that this is the one which is the data that we have the numbers 12 to 37, and
exactly.
Q1 I understood. Q2 is the median, and Q3 I understood. Okay. And basically, yeah, so the highest you said that since it is 23, which falls between 22 and 24. So 24 will be the highest, right? Hello?
Yes, exactly. Because this 37 is going to be like an outlier.
Yeah, outlier. Okay. So at the same
See,
time, at the
new
same
upper
time,
bound. See, exactly.
no,
Yes,
no, no.
please.
At the same time, when we say that Q1 is 14.5, basically between 14 and 15, the lowest one should be 14, right? But it is actually 12. So is it 12 or 14? Which one is right? Because when we say that the highest is in between 22 and 24, the 24 is the highest one in the after the Q3. And in the lowest wise, when we say that Q1 is 14.5, between 14 and 15, the lowest should be 14, right?
See, let me tell you. Okay, let me tell you. So in this box plot, the given data. So this is what the given data, right? So for this
Okay.
given data, what are we actually computing is that we just wanted to use this. We are just using this box plot, especially, okay, identifying all these no outliers Q1, Q2, Q3, especially to identify to detect the variability in the data, right? To detect the deviations or variability in the data. So this is one such way. Okay, box plot is one such way to identify, right? Are you getting this general aspect?
Yeah.
Spread of the data, right? So if this is going to be data, first of all, according to this box plot, it is going to be like 5 number summary, right? So minimum, maximum, this is what the original minimum maximum, right? And then we are just going to identify like Q1, Q2, Q3. Q1, Q2 is going to be like no half 50th percentile of your data, right? And Q1 is going to be like no first quartile of data, like no 25th percentile. And Q3 is going to be like 73 fifth percentile. This is what we have been calculating, right? And then in order to identify the variability or the deviation or the spread away from the mean, we are the actually box plot, it is also computing the new upper bound and new lower bound, right? So the new upper bound value is like no, which means what? It gives you like no Q1 is equal to 1.5 into IQR. Q1 minus, I'm sorry, Q1 minus 1.5 into IQR. So this is
Oh,
the range of value, another new range of value. So where we would be like already we would be using this no minimum and then maximum value. Can you able to point out what I'm just pointing out using the mouse cursor? Can you able to see in your
yeah,
screen? Yes. So
yeah.
this is actually new range. So new minimum value, new maximum value. So this 1.75, it's going to be like no new minimum range. This
Okay.
35.75 is going to be like no new maximum range, which means new upper bound. This is the lower bound actually. What it is determining using this IQR after identifying this IQR. Right? So in our case, okay, 35.75 is going to be like new upper bound. But we do not have a value here like 35.75. So what is the nearest greatest number is 24. Right? So that's why the when it is actually drawing the box plot, okay, drawing the box plot, it will actually try to plot the whiskers up to the maximum value, which is near to 35.75. If this is the exact value which is available in our data, then it would lead up to the 35.75. This whisker will lead up to that. But beyond that, the whisker will not go because this is the new upper bound and this is the new lower bound we have found it. And in the same case, for the new lower bound, if you see, it's 1.75, right? New lower bound is a
Mhm.
1.75. But this data
Mhm.
we don't have in our original data. 1.75, we do not have it. The new lower bound, we
Mhm.
do not have it. We do have like no nearest lower bound is only 12. So that's why the
Oh.
whisker is actually starting from the 12. If you do have a data like no 1.75, then the whisker will lead up to 1.75.
Mhm.
Are
Okay,
you
it is
clear?
coming from the 1.75 to the nearest one, whereas
Nearest one.
here it is 35.75.
0.75.
It is
It's the
actually the
upper line.
nearest one will be like 37.
No, 37 is the outlier. That's what. Beyond that upper bound.
Mm,
Why actually we
yeah,
are
yeah.
just defining upper bound? Because beyond that value, everything comes under outlier.
Okay.
Even in even beyond the upper bound also, even beyond the lower bound also. I do not know whether you can able to see my mouse cursor, which I'm now moving onto your screen. Can you able to
Oh, no.
recognize my mouse cursor?
No.
No? Okay, fine. So I have been explaining using my mouse cursor. Okay.
Okay, 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 okay. Okay.
So yeah, let me explain.
No, no, no. I got it. I got it now. I got
You
it.
got it right. So
Yeah,
if
yeah,
there is a point which is lesser than, for example, in your data, if you do have like no 1.70, for example,
yeah.
1.70, because this 1.70 is going to be like lower than the lower bound, then that
Yeah,
also
yeah.
will be become as a outlier, a new circle.
Okay. Okay,
So
okay.
especially box plot is one of the way to identify the variability or spread of the data or outliers, especially. Outliers means
Okay.
extreme data points that we need to focus on.
Okay. Got it. Thank you.
Do you understand this
Yeah,
aspect?
yeah, yeah. Yeah, yeah.
Yes,
Thank you.
thank you
Thank
so much. Thank you
you.
for referring the resources. Do you understand the resources which I've shared yesterday?
Yeah, I got a chance to look into few. Yeah, but the recorded one is not still uploaded from the Chef Solutions. So yeah, I've gone through like few of them. Yeah.
Ma'am, would you mind sharing those again? I'm new today.
Okay, Nafaiza. Actually, I have been seeing you in another batch. You have joined this batch. You haven't
Yes, I was in evening batch. That's goes on till 9:30, I think. It's a bit too late for me, so I joined here.
Okay, is that okay? Would you be able to can you able to catch it up with the concepts whatever we are just discussing?
Yes, ma'am. I have done this recently
Okay, fine, Nafaz.
as a
So
different course.
already it's been uploaded. I have been shared all the resources. Okay, it would be like uploaded in the LMS portal also.
Okay. I need to fix my LMS portal. Okay, no problem.
Okay, fine. No issues. Okay, fine. Thank you. So okay, guys. Hints of
So we are
hooks.
in statistics, right?
Exactly. We are in statistics.
Okay.
Erum. So Patrice, good day. Sorry, for you it's good morning. Right. Patrice, good morning. Michael, good morning. Arum, good morning. So I hope now everyone, as we discussed
Morning.
yesterday, yes, we have just started to discuss the descriptive statistics to understand our data. Okay, in order to understand our data, I hope everyone have uh, have do understand the concepts whatever we have discussed yesterday? Could you please confirm me? Guys, please give me a moment, okay? Give me a moment. So I do apology for or taking this time, guys, because I do some system issue. That's why I'm just quickly shifting over the system. Okay, so please do apology for the delay. I hope you guys can able to see the screen which I'm shared to you. So this was the coding we have been discussing in the last yesterday, right? So we have started to discuss with the descriptive statistics, guys. We have just started to discuss with the descriptive statistics. So mean, median, mode. We have just yesterday discussed like how to interpret with mean, median, mode. Yes, guys. So today I just, I think up to this we have just completed yesterday. Am I right, guys? Could you please confirm me? The same file I've just taken it on. I hope everyone can able to review this file, can able to access this file at your end. Is everything is fine, guys? Am I audible to you? Am I
Yes,
audible
you're
to you?
audible. I was able to open the file that you sent using Collab.
Am I audible to you, guys?
Can you hear me? No.
Yes, we can hear you.
Guys, am I audible
Suganya.
to you? Please confirm me. Am I
Looks
audible to
like you cannot hear us.
Okay, sorry. Okay, fine. I got it. I'm so sorry, guys. I'm so sorry. Yes. So we have just started to discuss with the mean, median, mode. I can hear you right now.
Cool.
Thank you. Thank you so much. So yesterday, we just discussed the factors affecting the quality, right? We have just discussed the factors affecting the quality. So why we are actually discussing this box plot and all those aspects, okay? Because to understand the variability, of the data, especially variability or deviation of the data. So you need to analyze, you need to focus on why this variability occurs in your data. Either it is actually by chance or by an error, or this is a randomness or the signal, okay, that you need to make a modification, either to handle it or to remove it. So all these aspects you would be investigating onto this data once you try to get this variability. You do have like several ways of detecting this variability, guys. Okay, so using the standard deviation, especially in all the descriptive statistics, okay, using the mean you can able to detect the variability, right? Which means if the mean is not equal to median, right? If mean is not equal to median, if the mean is so greater or no very lesser than median, then you can able to detect there is a variability is there in your data, right? You can able to detect it. And also with the standard deviation, range is also another factor that you can able to understand the variability. And then standard deviation. So standard deviation, box plot. So box plot. Okay. So likewise, you do have like several techniques, guys, several techniques that you can able to get like present, like what is an extreme value and what is an outlier, and how these actually variations actually impacting the data. All these aspects you can able to get it, guys, like z-score. Okay, there are a lot more factors are there, guys, in the statistics. So most frequent ways that we used in a descriptive statistics using the built-in function, you do have like a describe function, right? So in the describe function, you do have like a values like mean, median, right? So percentiles like no 25 percentile median, and then 75 percentile of your data, and standard deviation, and all these aspects you can able to understand, like minimum and then maximum value. Minimum and then maximum tells you the range of the value. So from this descriptive statistics, you can able to understand how your data has been following this variability and all those factors. So yesterday we just started with the range value. So what is the range value we have detected? Let me try execute one more time. So we identified the range as 26. Right? So what is the range tells actually? Range tells the spread of the data. The spread of the data, which means 26 minutes spread in delivery performance. Like how to interpret this range actually. You do have like a thumb rule. In order to interpret this range, you do have like a thumb rule. So what is the thumb rule? Either you can compare with the IQR, right? So if range is 2 times of IQR, which means if the range is so greater than, if it is a greater than the 2 times of IQR, then actually the data is actually inconsistent. So you need to investigate this inconsistency. If the range is actually, you can compare with the interquartile range. So interquartile range is going to give you the central tendency, right? So maximum distribution of your data with the 50 percentile of your data, like maximum distribution of your data. So this is the one way of detecting it, the inconsistencies. So another way is that you can compare with the standard deviation with the range. So if the range is actually greater than 3 times of standard deviation value. So if the range value is higher than the 3 times of standard deviation value, then you can say that the data is unusually high, So you can able to focus on with respect to the range, guys, with respect to the range value. Yes, guys, do you understand? So what is the range we have identified here? I think everything is executed. So if range, I'm just going to compare, okay, only with the range with greater than 2 times of, already we, yesterday itself, we just identified this IQR value. I hope we do have it in our data IQR. Interquartile range. We don't have it.
No, I don't think so. We have.
Only mean median mode we have just, no, it's there actually. So before winding up the session, we did this process, right? Like IQR value. We do have C. So IQR is nothing but Q3 minus Q1. Right? We do have the value of IQR already. Everyone get present this IQR value, guys? Can you able to get it? Yesterday we discussed in the box plot. Could you please confirm me? Could you please confirm me, guys? Can you able to recall this IQR value yesterday we discussed in the box plot? Before winding up the session, we have generated this data in order to identify the IQR. Can you able to recognize this coding? Yes, Insokpu. Okay. Erwin, could you please confirm me? Ramesh? At least can you able to recall the calculation part of it that we have discussed during the box plot? Can you able to recall it? We have just identified the Q1, Q2, IQR value in the box plot, lower bound and upper bound value. Everything we have just manually calculated. and how we can able to determine the outlier if the data points which is actually lower than the outlier lower bound and upper than the higher than the upper bound can be determined as the outliers. Could you please confirm me, guys, in the chat window? Can you able to recognize these concept of coding, like identifying the IQR, detecting the outlier using the IQR method? Ramesh, are you there in the session? I
Yeah,
cannot.
I already responded. Sukanya.
You have
Yes.
responded. I'm sorry. I was waiting for your response actually. I was waiting for your response. So since we have already detected in the last session, so IQR value is like 2.5 here. Okay, according to our data. So we are just going to get that. So 2 into IQR. Then you can determine that particular outliers are present in your data. Else there is no outlier. You got it? So there is an outlier present in your data. That's why it is showing like no range is actually greater than 2 into IQR. So what is the 2 into IQR? It's going to be like 5, right? So range is like 26. It's actually large deviation. So what is making the deviation? Only one point is making a deviation. That is a 45. The value is actually 45. It's actually dragging you with a larger deviation value, right? That's why it is showing outlier is present according to the range with an IQR. You can able to detect the presence of outlier. As well as with the standard deviation, we will also identify the standard deviation, guys. So what is the standard deviation? So standard deviation, before you understand the standard deviation, let me explain this concept, guys. So what is an average? Average is finding out the mean of it, right? Trying to adding up all the value, like add up all the value and divided by the total number of value. So that is going to give you the average or mean of it. Okay. So when you try to identify the mean in your data, for example, your mean is going to be here, right? So you need to understand first the variance. The concept of the variance gives you like how many, see the average of the deviations actually. So the data points have been deviated. Here also you do have like data points. Here also you do have like data points. Here also you do have like data points, right? So it is not with one data point. It is the group of data points because we do have like no group of data points are there. So what is the deviation value here? What is the deviation value here in this data point? What is the deviation value here? 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 And what is the deviation value here? So finally, it tries to add up all the deviation point. It does has some value, right? It does have some value. So finally, it add up all the deviation value and all the deviated value. So deviated value and then divided by the total number of values, total number of deviations. So that is going to give you the average, right? Like average of it. So it can be calculated like no x minus x bar the whole square divided by n, which means that is what is going to give you by the variance actually. So what is the standard deviation? Standard deviation will give you the square root of the variance. Standard deviation will give you the square root of the variance. So low standard deviation, okay, low standard deviation gives you the more consistent data. More consistent data, which means what? More consistency means what? If the standard deviation is very low, then you would be getting like no normal distribution or near to normal distribution. If there is a high standard deviation, which means it tells you there is a larger the deviation. The deviations are very higher. It represents the more variability. More variability. Are you getting? So why we wanted to consider the standard deviation rather than variance? So variance is actually finding out the average of the deviation. It gives you generally, guys. So mean is an average of all the data point, whereas the variance is give you the average of the deviation. Average of the deviation. So when it is doing some squaring value, right? Because when it is trying to identify the variance, actually it tries to give in a squaring value, right? So which means the unit value will get deviated. Okay, which means what? If your existing data point might be having a value in kilogram, okay, your data points might be having value in kilogram, but when you're trying to identify the variance, it would give you the unit value. The resultant measurement along with the unit value is a kilogram square, right? So in order to avoid it, in order to avoid this one, in order to maintain the similar measuring unit along with the data points, so you would be following the standard deviation. So when you're doing some square root of it, this squaring value will get neglected. So the unit value of the data point will follow the similar unit of the original data points, underlying data points. So standard deviation, actually it would be used for more for interpretation. It is preferred for interpretation. It is good for calculation. Okay. So variance will also be implemented during the machine learning model. Okay. In order to detect the performance, variance would be definitely will be implementing. So it is good for calculation purpose, but more for interpretation, the standard deviation would be taken on. Do you understand the concept, guys? So what is the formula for standard deviation? So standard deviation formula is going to be like summation of, okay, here also it has to summation of xi minus mean. X bar means mean, okay, mean of it. So the whole square divided by n, so square root of it, square root of the variance. Do you understand this aspect, guys? Could you please confirm me? Are you getting this scenario?
Can you take it again, please? Like just one more time.
Yes, let me tell you one more
Thank
time.
you.
So you know what is generally what do you mean by mean? So mean is nothing but, okay, average of the data point. Mean is generally nothing but average of the data point. How will you calculate? You will be adding all the value divided by the total number of value, divided by the n value, right? Adding up all the value divided by the total number of value. That is what it is going to give you the mean value. It's data point value. You will be actually adding up the data point value. That is what they mean. So what is the variance? Why actually we wanted to focus on the variance? Because in order to identify the variability in your spread, okay, variability in your spread. Variability in your spread, in spread of the data. I'm sorry, guys, I'm using the same page itself. Okay. So how to determine the variability? Actually, once when you try to identify the mean of it, mean is going to give you the central location or central tendency. In this case, the mean is not going to be like central tendency. Median is going to be like central tendency. But this variance will always be referred to the mean only. Okay, not the median. Variance during the calculation part, it always refer to the mean only, right? So even if the mean is actually slightly deviated towards the outlier, it would be considering only with the mean only. So what it will do, it will try to calculate the distance from the mean value to the each and every data point. So what is the distance between this mean and then this data point? What is the distance between this mean and this data point? What is the distance between this mean and this data point? So it tries to calculate the distance or deviation with that data point. So ultimately, it is going to calculate the average of all the deviations. So deviations means what? How will you find it out? You will be subtracting it from the mean. Each and every data point, if you try to subtract from the mean, you will be getting the distance, right? Distance can be calculated by subtracting your data point from the mean, so that you will be getting some difference. Are you getting it? This is what is can be calculated as a distance. Are you getting it, Michael? By finding out the difference between the data point and with the mean, you will be getting the distance of it. You will be getting the distance of it, difference of it. So when you're trying to get the difference of it, you can able to calculate the distance of it. Do you understand?
Yeah, got it.
Yes. So the variance formula is to square up the value and divided by the total number of value. This is what the formula for variance. Okay. Ultimately, it is trying to finding out the average. So average of each and every distance, it is going to calculate not only with this data point average, this data point one. So finally, it is going to sum up all the value and going to divide it by the total number of value. So what is the variance is going to give you? Variance is going to give you average of or deviation about the data point. Right? So this is good for calculation, but we are just going to consider the standard deviation. Why standard deviation? Because when you're it is going to do the square root of the variance. So when it is going to do it, so it will try to maintain the unit value according to the original data points units value, because it is actually squaring up the value, right? So always it is not only from here, guys, okay, even in machine learning model. Okay, I'm just taking you somewhere else, but get this aspect, okay? Even in machine learning models, there is a concept called mean squared error. You will be identifying the error of learning rate, like how your model is actually performing well or not. So this, in this aspect also, you will try to identify the deviations or no errors. Okay, errors in the form of the deviation from the actual value and the predicted value. So from the actual value and then predicted value. So what you would be doing? So this is the actual value, this is the predicted value. You'll be doing subtraction. So this would end up with the negative values. So when you try to find out the difference like this, so it would actually would be getting the value would be like negative values would be coming like negative -4 or -6, whatever it is. Finally, you're just going to do some sum up, right? You're just going to add on all these value. So when there's going to be a negative value, okay, then there could be you won't get like accurate answer due to this sign, due to this symbol, right? That's what this data points would be actually the whatever the computation, whatever the distance we have calculated, we will be squaring it up. When you're doing the squaring these values, okay, so 4 4s are 16. So it also inflates the error for sure. Okay, we will be discussing about all those aspects. The distance from 4 to actually it is going to inflate as 16, right? But the negative values will get disappeared. It will convert into a positive value. So -4 into -4 gives you like positive 16 value. So that is what we are just doing the squaring value. Do you understand this aspect actually? Can you able to get this aspect why we are actually doing the squaring value? Because in order to make this summation value to get the accurate sum value, we need to do some squaring value in order to negate this minus sign. So 6 6 are 36. So positive 36. The errors might be inflated, but in order to remove this one. So it's similar concept here. Similar concept here. So we will discuss all these aspects later. So similar concept here when it is trying to identify, because some x value might be like no greater than mean also, right? Greater than mean also some x value would be there. So that time you would be getting some negative values, right? So when you're just going to get the negative value, then some value you will not get going to get a proper addition. So that's why in order to avoid this sign symbol, it is going to get squared up. Right? So that is also going to get impact the unit value of your data point. For example, I'm just taking an example as a kilogram or any meter or kilometer, whatever it is, okay? It is also going to get impact with the a kilogram. So originally your data point might be having like kilogram, but due to the deviation, here also it is summing up the square and the unit value will also get changed up. So that's why in order to maintain the similar unit of your data point, I'm just giving an example. That's why we are just doing the square root of it. When you're doing the square root of it, we are actually trying to get back the deviation or no inflation. We are trying to reduce the inflation. It would be like inflated when you're just doing it, square it up in order to avoid the negative value, but we are just getting it back through the square root of it. But this is preferred for interpretability. Do you understand, Michael?
Yes, I do. Thank you.
I hope everyone can able to understand. Excuse me, guys. Give me a moment. So how to identify the standard deviation? DF of delivery time. Simple guys, .std. You do not require to know all the calculation. So the simple way is to give like std. Std is a built-in function that gives you the standard deviation value. Deviation. So what is the standard deviation value? It tells, standard deviation tells it's 7.6. So from this 7.6, how actually to determine? How to determine actually there is a deviation is there? Do you have any idea? Do you have any idea, guys? Yes, Nafais. Anybody? Ramesh? So for this data, okay, for our existing data, so this is our existing data, right? For our existing data, we identified mean, median, mode, and then range also, right? And IQR value also, and be able to detect like how much deviations are there. From the standard deviation, like how to interpret. So you can able to identify, guys. Okay, you can able to get present, okay, from the standard deviation. The value is actually deviated using the two different methods. Okay, let me tell you one method using the coefficient of variation. So the coefficient of variation, how to actually calculate the standard deviation divided by mean into 100. So in our case, what is the value?
$7.5. Was it 7.5? Standard deviation.
Think, yes, 7.25. What is the deviation value? 7.64.
Just little above. I can't see the previous.
I've shared this coding file with you, see.
Oh,
I've shared this coding file with you. The same coding file you can refer at your end.
yeah.
7.6. What does that mean?
Mean is
I've shared a coding to you guys. You can get the
yeah, I'm looking at it right now.
Twenty
5.5.
No, that is for customer ID.
Oh, sorry.
5.5 is for customer ID. We are just looking at the delivery time. 23.8
Yeah.
into 100.
23.8. Yes.
Yes, into 100. What is the result, guys? I'm poor in calculation. That too, this decimal values and all, I will not do it.
Uh-oh. You didn't say we have to manually calculate stuff.
You do not want to manually calculate. You can use a calculator. You can use a calculator. We do not require actually. We do not require to know all this stuff. But since you wanted to understand, right? You wanted to interpret. That's why we are just
Yeah,
getting this
just
math.
joking. 7.6.
Calculator. Use a calculator.
Yeah, doing that. Divide by 23.8 times 100. 31.93.
Exactly. Okay.
Yeah.
1.93. 31.93.
Sorry, 93277. This goes on like that, but yeah.
Okay. Exactly. So this is what the value of the coefficient of, this is called actually coefficient of variation, which means relative standard deviation. Okay, using this method, we can able to identify this 31.93, right? So there is a thumb rule, guys. There is a thumb rule. So you can determine as a low standard deviation, moderate standard deviation, and you can able to determine high standard deviation. So this low standard deviation, this percentage value, this will be giving in a form of a percentage. That's why we are just using it, right? So this percentage value, generally the standard deviation would be represented by the sigma. Okay, sigma. If this sigma value, it's like 10 to 15%. Okay, with respect to the mean, we have just calculated with respect to the mean, 10 to 15%. Then it is actually, your data is actually tightly clustered towards the mean, tightly clustered. Which means what? Data is consistent. So where is the mean is available, your data points, all the remaining data points are going to be like, no, most of the data points are going to be tightly clustered towards the mean. All the data points are going to be here. So which means your data is consistent. It is easy for you, for your machine learning model or for analysis also, to make interpretation or to do any business insights with this large group of data in a central tendency, right? It is easy. And what is the moderate range? So from 15% to 30%. So it would be like normal, but expected variation. There is going to be like slight deviation. So this also can be accepted. Okay, but you can able to still handle it, but still this is already accepted. But you see here, it's a greater than 30%. Okay, greater than 30%, which means the data is actually widely spread. So data is actually widely spread, which means inconsistent. The data is actually inconsistent. So you need to more focus on the on this particular type of deviations. So potentially indicates that the data is actually more diverse, more inconsistent. So it is not actually, sometimes most of the, even if you're going to build a machine learning models, okay, definitely you will try to avoid all these aspects of a data sometimes, or you will be reducing it, you will be filtering it out, because these deviations will in turn deviate the accuracy of your machine learning model during the learning process. The model parameters, what it is going to generate based on the features, okay, these deviated value will get result in deviation in the parameters, whatever the machine learning model is generating here. The same sort of deviation it will be getting out here. So this deviation impact affect the accuracy of your model. So that's why always it is, we are just focusing on dealing with such a high deviation value. So why we are just looking at model building process? Even for business process, actually you need to focus on. So what is making this deviation? So you need to focus on. So reliably, you will be setting up all the SLAs. So what is the SLA? So SLA is nothing but what? Service level agreement, right? Service level agreement in the business analysis. Okay, in the data analysis, so you will be actually can setting up the formal contract agreement between a service provider and the customer, okay, regarding the expected quality or performance metrics, time-based commitments of a service, whatever it is, okay, relevant to it, you will be deciding based on this factor. So this factor will make them to focus on, like what makes the delay, what makes this deviation. If you're just going and investigating it, so it would be giving like only one data point that gives you like 45 minutes of delay according to this data. So you need to correct that action. So you need to identify what is the root cause of it. Either it is a delivery route issue, either it is a delivery route issue, or it is that a peak time? Is that a peak time that actually the delivery is happened? So what makes the more waiting time for the delivery time? So you need to investigate. You need to investigate and identify the scenario, or by error it happens. So you should make sure, and you will be setting up some threshold. Okay, within 30 minutes of time, the delivery has to happen. So if it goes beyond it, then the business has to give like no compensation for the user. So likewise, no, the business will set their own no insights for actionable insights for their business solution based on these deviations. So they will try to improve the delivery time, and they will set up. So based on like no most of the data points have been following a certain time, okay, based on mean, median, mode, though they will be setting up all these factors. Do you understand, guys? How actually you want to determine? So another thumb rule, guys, another thumb rule is actually, this is most important aspect. Using the standard deviation, you can make use of the empirical thumb rule. This is called empirical thumb rule. So by general, okay, the normal deviation, okay, or the deviations, whatever it is. So it is a mean, right? Mean. So standard deviation like plus or minus 1 standard deviation. So plus or minus 1 standard deviation, right? From the mean, it is going to cover up like 68% of the data. 68% of your data. This is the basic thumb rule, guys. And plus or minus 2 standard deviation, plus or minus 2 standard deviation, right? It is going to cover up like no 95, approximately 95% of the data. So 3 standard deviation, plus or minus 3 standards deviation, it is going to cover up 99.7% of your data. So in this side also, in either side also, it is going to be same. Right? So the thumb rule is actually 68, 95, 99.
I'm sorry, can you repeat that again after the standard deviation and something?
Yeah, I will tell you. So when we discussed about the distribution of your data, right? So the
Yes.
distribution of your data point, where the most of the data points are going to be here. So this is going to represent the mean. So from the mean, okay, from the mean, like 1 standard deviation, it is going to give you the green zone, which means your data is consistent. Green zone.
Got it.
Right? Your data is consistent. So this is going to give you the yellow zone. So yellow zone means acceptable but needs monitoring. Yellow zone. Right? So this deviation from the mean, like 3 standard deviation, okay, it's going to be like no red zone. Red zone, which means unusual outlier. It represents unusual outlier.
But didn't we already remove the outliers using or we identified the outlier? We
We
didn't remove
identify.
it.
So we are using the different ways of detecting the outlier. Using the IQR, we just detected outliers. Right?
Got
Box
it.
plot is one of the visualization. We just detected outlier, box plot. Right? Using the range, we detected the deviation. Okay? We detected the deviations. And using the ST, standard deviation also, we can able to detect the unusual activity in your data. Right? Using this thumb rule, 68, 95.
Understood.
Understood? So according to our
Understood.
data, so what is the mean value?
According to our data. Wasn't it 23.8?
Okay, 23.8, right? 23.8. It is plus or minus 23 with 7.25. So plus or minus 7.25. So if you're just going to get it, so plus 23, so plus 23.8 plus 7.25. What is the answer? Let me erase this one, guys. Let me tell you clearly. Okay, green zone. And red zone. Right? I think approximately 16.55 to 31.05. Approximately, I'm just giving like 28.5 plus 7.25, whatever the standard deviation, right? So 28.5 minus 7.25. This is what? 1 deviation, plus or minus 1 standard deviation, right? 1 times. We are just doing it. Are you getting this range of value?
28.5 plus 7.2, 7.5, oh, 7.25. It's 36. Where am I getting 36?
Actually, it's 23.8
Okay, sorry, 23.8. I'm so sorry. Given wrong. This is what
plus
it
7.25. Yeah. That's 3105.
23.8. I'm sorry, guys. Minus
Oh.
7.25. So what is the answer?
3105.
3105.
Yeah.
And another one is minus when you're subtracting it. When you're subtracting it, you're getting this value, right?
Yes.
So which means the data points, okay, majority of the deliveries falls here, which means 68% of your data in your data, right? It falls in this range, green zone, majority of the data. So it is a good consistency. So those data points, which is actually falling in this range, okay, in the distribution, okay, if it is falling in this range of value, between this range, 16.55 to 31.5, 68% of your data is going to fall between this range. It is going to tell you the good consistency of data, good consistency. Your data is, these data are going to be like good consistency, whatever the data which falls in this range. Next, yellow zone. Yellow zone means it is 2 times, right? So 2 into standard deviation value minus 2 into. So what is the answer? 2 times of, like plus or minus, this is plus or minus 1 standard deviation. This is plus or minus 2 standard deviation. Yellow zone, which means what? 2 times of standard deviation with the, from the mean. So approximately it is going to be like 930 to 38.30. Are you getting? Which represent in this deviation. So this is what is going to be like 68% of the data are going to fall in this one. It's very good consistency data. So it is going to give up this deviation, right? 2 standard deviation, it's going to give you this range of value. So it determines like 95% of data is going to fall in this data. So this is also rare, but still likely to be acceptable. Acceptable, but needs monitoring. So these data points are also acceptable, but needs monitoring. So it might tend to deviate. But plus or minus 3 standard deviation, what would be the value? From the mean, like 3 times the deviation value. So which is going to give you this zone, up to this zone. So those values, which is actually lesser than this 9.30, right? Lesser than this 9.30 or greater than this 38.30 from the above range. You can consider from the above range. So it is all going to be like unusual or outlier. So that is in the red zone, unusual data point or outlier. So according to your data, okay, according to the available data, like 20 minutes might fall, okay, 20 minutes of delivery might fall in green, 23 minutes of delivery might fall in green, okay, green, or 35 minutes of data might fall in yellow, and 45 minutes of data might fall in red. So this seems to be like no unusual activity. Red zone. Do you understand the max behind the standard deviation, guys? Can you able to get this concept? So one standard deviation means the deviation from the mean. The middle point is going to be like a mean, right? So the middle point is going to be like a mean in the central distribution, normal distribution, or even in the skewed distribution also, whatever it is, even in the skewed distribution also, it is going to calculate from the mean. Okay, one standard deviation, two standard deviation, three standard deviation. So three standard deviation is a red zone, right? Two standard deviation, it's actually acceptable, but monitoring. You need to monitor these data points also. And this is the most consistent data and the reliable source of data. Can you able to interpret? Could you please confirm me?
Sorry, I have a question, right?
Yes, please.
So, I don't know, maybe you said it before, but of this calculation, what's the practical use? I mean, how is it used during, like, in a live data? What do we use these values for to calculate in our model?
Exactly. See, too many values outside this +1 standard deviation. If too many values are going to be there out of this +1 standard deviation, for example, right? So which means according to our data, okay, the delivery is inconsistent. You need to optimize the drivers, or you need to optimize the routes according to the business insights. According to the business insight. Are you getting it? So when you're just doing it for data analysis, okay, data analysis, you need to think about in the aspect of the business improvement, right? So if too many data are away from this one standard deviation, then it gives you the insight that delivery process is actually inconsistent. So you need to optimize it. You need to provide the reliable service. And also you need to isolate the root cause of it. What is the root cause of it? Either the bad route, or no, it might be the peak time, whatever it is. You need to identify the root cause of the deviations from this one. Because the service is becoming unstable, right? So you need to investigate whether it is a workload or logistics, whatever it is. What is the SD is actually trending higher?
So we have to
According to
find
the
out
business.
why the deliveries are getting late, and we have to fix that problem.
Exactly. You need to consider, you need to focus, you need to you need to actually investigate in more aspect. So what makes this actually inconsistency happening? So what are the factors that is actually making this inconsistencies in your data? Right, according to the business aspect. When it comes to the model building, right, machine learning model building, so there's too much of deviation of data, okay, like transformation, like you would be actually using the IQR analysis, you can able to reduce the outliers. Using the z-score method, you can able to reduce the outlier, but you can still reduce the outlier, but you cannot able to remove the outliers completely. So when you see the box plot, okay, using these methods, okay, the box plot might be giving like too much outliers sometimes in your data, which means it gives you because real-time data, right? So we cannot able to expect the real-time data, all the features are going to be like consistent. Definitely it is not there. You're going to get only the inconsistent data. That's why we are just discussing all these factors. So in this inconsistent data, you would be getting like all sort of most number of outlier data is going to get it. So you will be using the method to reduce the number of outliers. But you cannot remove it completely, because when you try to remove the outliers completely, you will be ending up with a loss of information, right? Either you can reduce it, or depend on the usage, okay, you can able to use the transformations onto this data. You do have like a different transformation technique, log transformations or whatever different transformational techniques are there. You will be implementing onto such feature if this feature is the most optimal for predicting your target variable. If this particular feature, okay, if the deviation is highly skewed due to the high variability, okay, you cannot able to give your model learning process the same. You need to transform this data. So the transformation will try to adjust the distribution actually. Will try to adjust the distribution, makes the reduced skewness without modifying the underlying underlying meaning of the data, like underlying distribution deviation of the data. Try to change the y-axis count or log transformation, right? It will do some transformations onto the values actually without changing its original meaning of the data. So that's why we do require the statistical technique. So when in case of the model building, you do definitely you will be doing some transformation onto such a highly deviated data, because this might actually deviate your machine learning model also, right? You will be implementing during the implementation process. When it comes to the business insight, you need to investigate it. And if this value it occurs by error, you want to remove it. So we have just discussed what are the factors that is impacting the data, right? If it is occurs due to the randomness, then you need to handle it, because this should not impact the other group of values, because 90 percentage 99 like 99 percentage of the data, it's actually delivery is happening within a time limit, right? So this deviation should not impact this good delivery. Actually, your process is going good only. So in general, if you are just analyzing it, then we will be ending up with okay, our delivery is happening good. But only with the statistics, we can able to identify, okay, what is this actually making this deviation? You will not rely on the average. You will not rely on the mean in this data. Okay, you will not rely on the mean in this data. When you understand the real statistical aspect, you will rely on only the median value here, because mean is getting deviated towards skewness. Yes, towards the skewness. That's why you will not rely it. That's why we need a interpretation with the statistics. Are you getting it? Do you understand some general aspect of the data, like how you wanted to interpret, how you
So
wanted
in
to
machine
identify?
learning model, we don't have to look at the mean, right? We have to look at the median.
Exactly. See,
Okay.
even in machine learning model, exactly, yeah. Whenever there is an outlier data, skewed data, right? You have to choose only the tool which is as the outlier. For example, feature scaling technique. Shall I delete this page, guys? Is it okay? Shall I delete this page? So in case
Yes.
of feature scaling, okay, in case of feature scaling is one technique which is to normalize all the range of values, okay. You do have like a robust scaling. You do have like this different type of scaling, normalization and standardization. Okay, you do have like no min-max scaling, okay, min-max scaling, max absolute scaling, okay, max absolute scaling. You do have like no different scaling technique. So robust scaling is one such technique, okay, which if you go and if you go and see everything is going to available in your built-in only, right? Built-in function only. If you go and see the formula of it, it would be using a median in its formula, because this robust scaling is robust to outlier. So for this skewed distribution data, if you want to do some feature scaling, then you can implement the robust scaling onto it. So robust scaling would be the best tool to do the scaling process for this particular feature. For example, if each feature is deviated, if this feature is optimal for model building or machine learning model, for example, then you are during the scaling process, you can implement the robust scaling, because robust would be using the median value. Because this is a skewed, right? This is a skewed. So median is robust to outlier. Are you getting this aspect? This in terms of the feature scaling technique. So robust scaling is one of the feature scaling technique. So with this standard deviation, guys, okay, with this standard deviation, you can able to get to present. Like, see, it's easy to identify the standard deviation. It is going to give you like 7.64 or whatever the matters, okay? But how will you detect? How will you identify? How will you interpret with the 7.64? So you can interpret in this manner, whatever we have just shared it right now. Guys, can we go for 5 minutes break? We got 5 minutes break.
Sorry, I didn't understand that.
No, break, 5 minutes break.
Oh, sounds good.
Yeah.
Sounds
Okay.
good. Thank you. Back, are you back, guys? Are you back? Could you please confirm me? So what is the conclusion? Okay, I'm just giving some simple aspect, guys. But we can define many stories also. Like storytelling is one of the aspect of data analysis. We can still build up with a lot of stories. But in general, okay, without statistics, you might you might be getting only the average value. I hope everyone is back, right? Could you please confirm me, guys? Everyone is back. Okay. So without statistics, we may assume only statistics, we might assume only the average, right? Only the average delivery time, whatever it is. And based on it, you will be actually taking up the decision. But with statistics, you can able to perform the real performance, with a specific skewness, okay, deviation on the skewness. Real performance with specific deviations in skewness, and can provide a data-informed operational actions, and can take data-informed operational actions to improve reliability and customer satisfaction for your business. So normally numbers don't lie, guys, okay? We all know that numbers don't lie, but they need actually the real interpretation. So understanding the story behind the data is the first stop in any data science journey. Okay, in any data science journey, understanding the story behind the data. So these are the stories that we can able to make it out, whether the data is skewed or not. So according to the box plot, you see the long whiskers shows you that there is no much data distribution here. That's why you cannot able to see here. Only the most of the data points have been clustered around here in this region, in this range of values only, in this region. So even in the distribution also, you can able to see it. Box plot will also give you the distribution. And after the median also, you can able to see some larger space in the box actually. From the 50th percentile, so from the 25th percentile to 50th percentile, okay? So first 25 percentile of your data, you do have like lot of deviations. You can able to get it. Only one, maybe one data might get deviated, or a few data get show these deviations. So this is the left skewed. Left skewed means what? Negative skewness. So this is the right skewed or positive skewness. So these are the whiskers. Whiskers will show you the skewness of your data. understanding these aspects is to much more, guys, if you say, if you wanted to investigate, okay, in the deeper aspect of your data, then you can use all these formulas, okay, to detect what is the high variability, which data is actually making the high variability, all these inspection you can do it. But generally, guys, generally we will be using only these plots, like distribution plot, box plot. With this itself, we can able to get the deviation of your data, right? See, all these calculations we can able to do only with a simple function called describe. Data or DFR, I think. DF. Describe. Can give you the descriptive statistics of your data. So total number of records, 10 records. So what is the mean of it? Mean says like 23. What is the median of it? Median says 21. Okay, there is a difference. Okay, mean is like higher than the median, which shows that it is a positively skewed. The skewness is towards the right hand side. You can able to determine right now. Got it? And you do have like a minimum value is 19 and the maximum value is 45. You can able to see what is the 25 percentile of data lies within the values of 20, like less than or equal to like 20 minutes. So first 25 percentile of data, okay, it is going to, the delivery time is going to be like lesser than 20. So then 50 percentile of your data, okay, the delivery time is going to be like less than 21 minutes. So like 50%, like maximum is going to be like less than 21 minutes. And you see 75 percentile of the data, the delivery time is going to be like less than 22. So all these 3 percentiles of the data, like up to 75 percentile of your data, the delivery time is going to be like less than or equal to like 22 minutes. But you see the maximum duration ends up with 45. There is a huge difference, right? From the 75th percentile of your data, last 25 percentile. So this shows like after the 75 percentile, last 25 percentile. This divides the data into 4 parts, right? So this has the larger deviation. You can able to get it from the 75th percentile, what is the value? From the maximum, what is the value? So here you can able to see the deviations. For standard deviation also it is there. And with this also you can able to interpret. So what is the 2 times, 1 time standard deviation, 2 times standard deviation, you can able to interpret. So what are the possible data points would be in the zone, green zone, red zone or yellow zone, whatever it is. Can you able to interpret right now, guys? Could you please confirm me? Are you all clear about all these descriptive statistics? How to make an interpretation with the descriptive statistics from your data? Could you please confirm me? Are you all clear about this concept? Arum, Hinsoku, Michael Ajay, Nafaiz, Ramesh. Clear? Yes?
Yes.
So let me give one more data for you. Guys, I'm sharing it in the chat window. Okay, I want you to create a data frame for this data. I have given in a dictionary format, guys. I have given in a dictionary format. Okay, so the data is actually OTT data. The OTT data means what? So Netflix, okay, or you will be watching a movies, right? OTT platforms. So it is going to consist of the features like watch time, language, and then age group of a people. So you do have like only 10 days, 10 data, okay? Like age group of 12, 13, 11, 15, 12, 15, 10, 6, 45, 60. So these age group people, what are the languages they have been actually watching? What language they have been watching the movies or TV shows, whatever it is, and how many hours? Like watch time gives you the number of hours. Like 1.5 gives you 1.5 hours. 1 gives you 1 hour. 1.5 gives you 1.5 hours. So this is the data. So this is the data for you. I want you to identify, I want you to actually understand the data and summarize the data and give me some interpretation about this data, guys. What do you understand from this data? With respect to watch time, with respect to language, with respect to age. Is it okay, guys? Can you able to do it using the descriptive statistics? You wanted to understand this data.
I'm sorry, I can't see the headings.
I've shared you the data here.
Oh,
So when you create a data frame with this data, you can able to see the data like this. So watch time, language, and then age. It is an OTT data. So OTT data, like you will be watching a movies, right? So 1.5 hours, this age group people, okay, are watching the movie or in the language like English language for 1.5 hours. So like this type of a data you need to interpret. Can you give your insights about this data?
okay.
Ramesh, you are clear about the task? Erum, Hinsokpu, Patrice, are you clear about the task? What do you understand from this data? What kind of interpretation? Okay, what do you understand from this data? What are you getting, the insights, when you are just looking at the data? Like after learning the statistical aspect of it. So what you can able to see from this data?
Like which age group is watching which type of movie?
Anything, any aspect you can able to explore the data.
Yeah, the watch time of the movie,
Yeah.
1.5 hours.
Okay,
Watch time of
so I'm sorry. I'm sorry, I didn't mean to disturb. So we have 10 records. We can see that. The mean is 2.5 watch time, and average mean age is 19.9, so 20. Standard deviation 1.5. So we have all this, right? Is that what you're
Yes,
asking?
exactly. See what are you getting? What are the insight you are just getting from these measures?
Oh, yeah. The 25%, sorry, minimum is 1. Yeah, I just did a DF describe.
I got it. So you got the values, right? You got the values of what is a mean, what is a standard deviation, everything. You got the values, you got the measurements. But what are you getting? What is the insight actually you're getting? So that is what the most important aspect. You can tell any stories, guys. Anything you can share. Say, I'm telling you, you will not have definitely one answer for this one, right? You can able to tell many stories from this actually data according to the statistical interpretation. You can share many information, as many insights, whatever you're just getting, you can share it to me. There is no one particular answer. What is the story you can tell from this data? Okay, got it, Insopu. Mean is actually greater than median. It is positively skewed to the right. Okay. Guys, are you sharing anything? Are you communicating to me? I cannot able to hear. Yes, Ramesh. Okay, this is from the descriptive statistics. Okay, so what do you understand from this descriptive statistics? What do you understand from this descriptive statistics? Can you please share? Can you please interpret and share? Yes, Nafais, I got you. I got your plots of distribution, all this aspect. Guys, we do have like a lot of built-ins, guys, lot of built-in to show up. So everything, see, so mathematically we discussed a lot of calculations in order to understand the in-depth aspect of all these tools, right? What is the standard deviation, like how to interpret, but it is easy for us to generate. Once if you learn to interpret, okay, then if any data is given to you, you would be actually can able to develop any this thing. So low standard deviation, is it low standard deviation? Okay. How do you say it is a low standard deviation? It's 1.25, 1.5. Okay. Did you compare with the mean? So with respect to what feature the low standard deviation in Japu? With respect to watch time or age? So guys, one specific thing is that you can able to do this descriptive statistics only with the numerical features, not with the categorical features. Categorical features, you can explore the mode. Okay, most frequent value, you can able to get it. Only mode alone, we can able to implement onto the categorical type of features. So yes, in SOPO, what is which feature? We do have like two features, right? We do have like watch time and we do have like a age. So for which feature the standard deviation is low? With respect to you do have like three features in this data, guys. One is the watch time, language, and another one is the age. What is the insight you're getting? You can share. Please unmute and then share it to me. What do you understand? Okay, guys. So if you see, if you just identify the mean for the watch time, okay, what is the mean for the watch time? You're just getting 2.5, right?
0.5.
So watch time mean is actually 2.5, which means on an average, see the mean and then median is not equal. Okay, it is little bit, okay, according to the watch time, it is slightly deviated. It's not highly deviated, it's slightly deviated, like 2.5, right? It's not, both are not same. Some deviations are there, right? So on an average, okay, in this data set, the people in the customers in this data set are watching like 2.5 hours of their watch time, their OTT, they are watching, right? So median tells you like half of the customers from this data, okay, are watching less than 2 hours. On an average, 2.5 hours. Okay, all the customers are watching 2.5 hours, but half the customers are watching like less than or equal to 2 hours. Their watch time hours are 2 hours. The most frequent hour, okay, the most frequent hour is going to be like 1.5 hour. So most frequent hour by the customer, the watch time customer. So when they are trying to identify, okay, this statistics, so they will try to create a show with a 1.5 hours, because this is the most of the watch time hours, right? So they will try to fix the shows in future shows with the 1.5 hours. Or they will try to improve the average watch time hours. So by setting this 2.5 hours as a threshold, they will actually create some they will enhance the movies or whatever it is to increase this value, to increase this average watch time value. Once if they identified this average watch time value. Are you getting, guys? So you can deliver, you can tell the like this sort of a stories by identifying this mean and median and mode. So these are the stories you want to get in. Can you able to understand how you wanted to understand the data?
Yes.
Yes, Arum, Nafaiz. So distribution, if you see, it gives you like skew distribution. It's not normally distributed. The watch time, it has some high value in it. Even in the watch time hours, it has some deviations. This distribution is called the skew distribution. The density of the data points are going to be like nearly between 1 to 3. Okay, between 1 to 3, which means what, from 1 hours with less than 3 hours, like most of the data points are going to be there, especially between the 1 and 2 hours. So that's why half of the data point, like half of the customers are watching between less than 2 hours. So which means most of the customer are going to fall in this region. That's why always in the skewed data, you wanted to consider the median value. Median gives you the most of the distribution of your central tendency. So can you able to get it? So median gives you like 2. Mean gives you like 2.5 here. Mean gives you 2.5 value. Median gives you the 2 value. So median is going to represent with the maximum distribution of your data at this point. Are you getting, guys? Can you able to interpret in this manner? Are you getting the concept? Hinsoku, Ramesh, whatever I'm just sharing. Are you admitting it? Nafaiz. So you can also, we have right, some deviation are there. So is that as outlier? Is that an outlier or extreme? So in order to check out, you can make use of the box plot. Even the violin plot is also similar to the box plot. You can make any of the visualization to explore the skewness. Yes, we do have like extreme skewness. It's one data point which lies in the range of like 6. So one circle will shows you the one data point. So these are the whiskers, right? You know, this is the minimum lower bound, upper bound, and then Q1, Q2, and then Q3. So Q1, Q2, and then Q3. So from the Q2 to Q3, there is some deviations are there, like variations are there. It's not deviation, like spread. The spread of variation is there. So towards the, it is called the right skewed. It is called the right skewed. But one data point actually it is showing the deviation. That is the watch time hour of 6. The remaining data are going to be in the fall in the range of values. Right? So violin plot will also like similar to the box plot. You can able to understand. This is the violin plot. Right? So inside the violin plot, you can able to see the representation of the box plot. So based on the box plot only, the violin plot will also show the skewness towards the right side. It is the right skewed or positive skewness. So there is some deviations or spread of the data, like highly deviated data towards the right hand, where the most of the distribution of your data points are going to be in this region, median value. So based on the median value. right? So you know the 50 percentile of data. So this represents 50 percentile of your data here. Middle 50% of your data. This is the IQR range, and this gives you overall range. So standard deviation for both the watch time and then age. So watch time gives you like 1.5 hours, 17.7 for the standard deviation. So you can also able to get that no age is about age is actually getting deviated actually. So I have not interpreted here with the respect to the standard deviation, especially. Yeah, in this data, I did not do that calculation part of standard deviation.
Can you
Calculation part I
please
have not
update
done.
the file? It's
This
not
file,
saving.
this link I have not shared it to you guys. This link I have not shared it to you. So I have just roughly made this file. Okay, roughly made this file. So don't get this interpretation. It's a true, like, no, some values might not be relevant.
The previous one also, it's not saving.
It's not saved here, previous one.
No.
Can you please do the refresh at your end so that you will be getting refresh at your end? So this file I have not shared it to you. Okay, correlation matrix is another matrix in order to identify the relationship. I don't think so that we have discussed about. Have we discussed about the correlation matrix already? It's similar to the missingness matrix we have discussed, right? Heat map. They're similar to it only. That is a missingness ratio. This is the relationship between the two variables.
No, we
Okay,
haven't
correlation.
discussed it.
Yeah, we haven't discussed, right? Got it. We will discuss. This correlation is also another statistical measure in order to understand the relationship between the two or more variables in your data set, a pair of variables in your data set. So based on this relationship, you would be performing a feature selection for your model building. So which features are related to your target variable. So all these aspects we can able to explore it. Yes, even with the covariance matrix, we can able to do this relationship, understand the relationship, but covariance matrix is not interpretable. The values which is going to be lie here, it is not, it is up to the unit value of the data points. But whereas in correlation matrix, okay, correlation matrix, it is going to have some definite range of values between like -1 to +1. You can able to make it interpretable. So near to +1 or -1, it is like a strong relationship or positive relationship or negative relationship. But if it is a like less than 0.5, it is like low relationship. Okay, we will discuss. But the range of values is going to be like strict between like -1 to +1 in case of correlation matrix. So correlation matrix is the best matrix for comparing the relationship between the variables among the variables in your data, right? So 0.7 means what? Age and then watch time is like moderately related to each other. If any updation in the age feature might get impacted the positive relationship, okay, because this is positive 0.5. So with this ratio, this value will also gets updated. This value will gets impacted. The watch time will also gets impacted, okay, based on this value. So that is what the relationship that is there in your data, according to your data, right? So we will explain to you. I will explain to you. But covariance matrix will also define the relationship, but we cannot able to interpret it. It is not interpretable. It is not interpretable. So I've just displayed it to show you. There is also another matrix is there. So range, variance, standard deviation. So we can be able to display what is the range of it, what is the variance of it, what is the standard deviation of it. Everything you do have like a built-in function. So I have shown you some way to identify like to do some calculations with the standard deviation to identify what is the deviation with the range. So what is the deviation? You can able to check it out. IQR value also. With the IQR value, you can able to define it. So box plot. This is for watch time. And I have also identified the IQR method. So IQR method gives you the interquartile range, which means it detects the outlier from your data. So consider, guys, your data set is going to have like crores of data, like millions of data. You wanted to identify what is the outlier data, right? So this is going to give you the outlier. So what are the data points in the ninth record, especially the ninth record? The index position is 9. Okay, index position is 9. With respect to your watch time, the data point is 6. It is the outlier data. So it gives you the upper bound and lower bound value. Those data points which are actually lesser than this lower bound or greater than this upper bound would be considered as an outlier according to your data. And this 6 actually lies no above the upper bound. So it is going to be considered as an extreme data point. Only this is creating the deviation in your distribution. Are you getting it? When you're trying to see the distribution, using the histogram plot or box plot, okay, the deviation is showing because of this value. That is what you can able to extract using the IQR method. Right? These deviations for age, again for the age. If you see the distribution of an age, we can also able to get the deviation in the distribution of the age also. So vertical box plot for the age, you see the deviations. You do not have a upper skewness at all, upper whisker at all. You have like no a large huge deviation in the data points. Right? Are you getting it? And using the visualization tools also, like graphical method also, you can explore the data. So it is a bivariate analysis. So you can able to explore this analysis using the 3 format, guys, especially. Okay. To understand the data, you can able to do it in the 3 types of analysis. One is the univariate analysis. Another one is a bivariate analysis. Another one is multivariate analysis. In order to understand your data, univariate analysis means single feature. Like you're just displaying here, right? Box plot, only age feature. You're just only using the age or only using watch time. Any one of the feature, you're just using the histogram or scatter plot. Okay, these are all some of the visualization tool you can make use of it. Scatter plot or box plot. Okay, so you can able to use any of the feature, like with various plots are there. Okay, to see the distribution of the univariate analysis, single feature. Bivariate analysis, it is the relationship between the 2 or more feature. Two features. Two features. Relationship among the 2 features, it is a bivariate analysis. If it is a greater than like 2 or more features, then it would come under the multivariate analysis. Correlation matrix, it's a multivariate analysis. Pair plot is going to be like a multivariate analysis, where you can able to make a relationship, not only with the visualization tool, you can also able to group by or no pivot table, whatever it is, cross tab. Okay, so you can able to explore your data. Any tool, if you try to explore your data with the relationship between the 2 or more variables, that will come under the multivariate. If only 2 variables relationship, that will come under the bivariate analysis. Only one feature you can able to get it is a univariate analysis. So histogram, box plot and all, it's a univariate analysis. Right now it's a bivariate analysis. The combination of the relationship between the 2 features, like language and an age, for this data, bar plot. So you can able to get it like which language actually the most number of values have been there. Tamil language. This is actually going to show you the interpretation. Tamil is showing the topmost language which has been watched by the users. So that's what interpretation you're just getting it on, right? From this data. So English, Hindi, Marathi. Sorry guys, I'm from India. That's why most of the language are coming from Indian guys, right? So Hindi, Marathi, Telugu. Okay, Ramesh belongs to Telugu. Ramesh?
Yeah.
Yes.
Yeah,
So
yeah.
we do have like no. Yeah, I belong to Tamil. I belong to Tamil. And I hope other belongs to English, right? So we do have like languages. And also you see the language and then watch time with respect to the watch time. Here with respect to the age, here with respect to the watch time. So here the 60 years of people, like which means what? The maximum number of age group people are watching the Tamil movies. So nearly like 40 plus age group people are watching the Telugu movies, right? So nearly now 10 plus age group people are watching the English movies or English language type of a TV shows or movies. Similarly for Hindi also, with respect to the age, you can able to interpret. So less than 10 age group people are watching Marathi language. So with respect to watch time, you can able to interpret with respect to the watch time. So language with respect to the watch time. So Tamil actually it's been watched by the most watch time hours will completely have the Tamil people, Tamil language. Like they are watching for the maximum watch time hours. Tamil language has been watched by the maximum watch time hours. I'm sorry guys, I'm just and Telugu people is watching like no 2 hours or something like that, 2 hours. Marathi is nearly 4 hours. Marathi language has been watched by the 4 hours, and Hindi language it's been watched by the 2+ hours. Like English language, like 1.5 hours of their watch time. So these interpretation you can able to do it. This is also another univariate analysis to check out the frequency. So what is the language? If you independently check, like number of frequencies, it is going to show you the number of records fall in this category, belongs to this category. So we might have observed in the above analysis, Tamil is the most top no record, no most top value, either with respect to the language or with respect to the watch time, right? It shows the maximum distribution in this bar plot. But when you see the total number of records, it's only one record. So that's why no, when it comes to the statistics, you want to do the analysis with by use of the multiple tools. Only then you can able to get the correct interpretation about the data. Otherwise, you might have think that okay, maximum number of people are actually watching. So you might have think like that. But what is the real interpretation? When you explore with the different tools, you will get to know it. So only one record is being fall in this particular Tamil people, even for Telugu. So maximum number of customers are belongs to the Hindi language, right? English language. Next to Hindi language, English language. The maximum number of no customers for this OTT platform. Tamil, only one people is there. That too, their age group is 60 plus. Okay, and they are watching Tamil movie. Similarly for Telugu also, only one customer is there. Okay, and he has been watching like no, he's belongs to nearly 45 plus of age, and his watch time hour is like two hours of time. Can you able to interpret? Can you able to understand your data in this aspect?
Yes.
So you need to use the various tools, guys. So here only language alone have been implemented. So when you try to look at only the language alone, okay, you see which is the most topmost language in this OTT platform, which is being watched by the most number of customers. It is an Hindi language. The Tamil did not come here, see, because Tamil has been watched by only one customer, right? Telugu also, Marathi also. So Tamil did not stand up top here. Tamil, only the English, Hindi actually stood up the top, and next to Hindi, English. So number of customers, total number of counts according to your data. So the way you are actually trying to interpret your data, and you can able to understand. Not with single analysis, but with various analysis, you can able to get to the right interpretation about your data.
Can you share this the link to this?
Exactly. See, yeah, I do share, but I'm also telling. I
Yeah.
didn't do this standard deviation calculation part here. Okay, I missed it some because yeah, I have not done in this data. I have to do it, but you can do it. But don't rely on
Yeah.
the values here. These values are not accurate. Whatever it has been given here, it's not going to be like accurate, relevant to your data set. That also you just get it. Okay. You just compare and you will try to understand.
Sure.
Sorry, guys, I didn't make it more, precise information in this particular text. It's not precise. I think, wait, let's give some access permission for you also, for this page also. So, okay, guys. So today in this class, I'm just completing this descriptive statistics. I hope everyone understood this concept of descriptive statistics, like how you wanted to interpret this data. Similarly, you can explore with some examples, guys. Examples, and try to practice with the more examples, more relations, so that you will be getting some clarity about how to actually. You can also still develop the data storytelling aspect with respect to the data. So guys, I do also would like to share one data, actually one coding file. Okay. As I hopefully this is, I'll be sharing one project file. Okay. So you can able to get to understand, not only with the descriptive statistics there in that file, actually you do have like very detailed description for each and every of your task, not only like finding out the anomalies, finding out the outliers, or finding out the inconsistency in the data, as well as with respect to their descriptive analytics, you would be getting a lot of interpretations. So just go through this file, coding file, especially the data science project coding file. But don't find it too complex. See, if it is too complex for you to interpret, just leave it, guys. Don't confuse yourself. Okay, don't confuse yourself if it is difficult to interpret at your level. But still, then I'm just sharing it to you. Wait, let me. It is a strategic recommendation, customer data-driven insights. So don't execute it, okay? Just open in a Google Colab file. I have not shared the data. Data also you'll be getting it from the, you'll be having the problem statement, right? You'll be having a problem statement in that particular coding file. And for each and every of the action, like handling with the missing values or whatever it is, you have some description. It is easy for you to understand if you read the description and if you see the result of it. Still, if it is confusing, please don't get yourself confused. I've just shared it in the chat window. With the real-time data, guys, with the real-time data. I've just shared a complete project. Okay, it is built using the unsupervised machine learning algorithm, like a clustering project. Okay, so it would be like a best example that you can able to create some insights from this data.
I only have the OTT. Did you say something else?
Are you sending
Yeah,
the link?
No. I'm just sharing the notebook file. It's getting uploading.
Okay. Thank you.
Makes sense.
It's uploading actually. Just a notebook file. If you want to work with the data set, even the problem statement, you do have like a link, like you see a data repository. You can click onto this link to download your data. Okay, let me try to open that file also in the meantime, because it is getting uploading. Guys, it's uploading, okay? It's uploading. I've just uploaded, but it's still loading. Okay, it's about to complete. I'm just getting this aspect whether this Zoom call might end automatically. So that is what the aspect I'm just thinking out of. Insoku has left. So let me attach this coding file also along with the LMS portal, okay, in today's session. You can keep this as a reference to explore. Okay, it's been successfully uploaded, guys. You can download the coding file. So here also you can able to see it. So this is what the problem statement. You will be getting some data when you are clicking onto this link, use AI machine learning repository, and you can study the problem statement. And what are the processes they are doing in this particular project, you can able to explore. They have given detailed information. That's why I've just shared this project with you. Because most of the we are just going to do it in the session. Everything we do not have like no detailed information. We'll be more focusing on the work, okay, not with a description and all sort of thing. Okay, this is going to be like complete project with a detailed description. So what are the steps they have been carried it on? So with these steps, for each and every of the actions, right? So this is what the data set you would be receiving. But model building is not going to happen with this data set. You'll be doing some feature engineering tasks in order to prepare your new data set using the RFM analysis, recency, frequency, and monitoring. Okay, you don't go up to there. Okay, up to you can able to like checking out what is the information, what are the description they have given related to the information, what is the summary statistics with the data, with the object type data, with the numerical data, what is the interpretation they are just making it out with the summary statistics, right? So all this interpretation you can study and you can able to understand like what is the deviation and how they are handling the missing value, how they are just displaying the percentage of the missingness, because it is helpful for the business people to understand if you just show up everything in a visualization format, right? It is easy to generate, guys. It is easy to generate. Don't get stuck with the coding, guys. Always, it is easy to generate the coding according to your need.
It
And
says
just a missing value.
we have no application to download this file. So where do we have to
No,
open?
just
Google Chrome?
download it. Go to the
Yeah.
go to the Google Colab. Okay,
Oh.
just go to the Google Colab file and then go to the upload option, and then choose the file from here in this space.
Okay, thank you very much.
Choose the files. Thank you. You just explore what they have done to deal with this missing values here in this data set, and what are the other ambiguities that is present in the data set and how they are actually handling univariate analysis. Okay, for each and every feature, like with the stock codes, okay, with the description, okay, with the duplicate values, okay, in every individual feature, you'll be identifying some anomaly. They are actually collecting the stock codes, whatever it is. Like from the 5 lakh records, they will try to clean up till up to 3 lakh records. They would be finally getting the 3 lakh something records. They will try to remove all the finding out all the ambiguity that is present in the stock codes, and then description. You see the stock codes, the ambiguity present here as a post. They'll be identifying all the remaining values are going to consist of this range. So only through visualization, they'll try to show up everything. Every description you will be having below, guys, for all of your output, every of your output. So inferences about your answers. So it is easy for you to understand with this inferences. So it would be helping you. So up to this, you can able to. So don't go beyond that, okay? Because we have to still have a lot more things to discuss. Yes, finally, data cleaning process has completed with 3,99,573 records. After the feature engineering, still the outlier treatment, most of the tasks are going to be there. Just explore and then come to the next week, guys. This would be a good task for you to explore it. And also, I want you to work on with the simple data, like how we just explored during the session, right? Simple illustrations, you can still work onto it. Okay, guys, I hope you have learned something new in this stuff. Could you please confirm in the chat window? Have you learned something new related to the statistics? Do you understand the concept, whatever we have been discussing about the descriptive statistics? Are you getting some in-depth aspect of the data, how to understand the data, everything?
Of course.
Okay, fine. Thank
Thank
you.
you.
Thank you all. Bye. Next week we will discuss with the inferential statistics. Bye all. Bye. Thank you. Bye. Thank you, guys.